Good afternoon, team. I'm Mason Graham with the Brock Environmental Center. The Brock Environmental Center is located just right outside of Virginia Beach, Virginia, and it's one of the greenest buildings in the world. It was originally funded by the Chesapeake Bay Foundation, which they still maintain ownership of, and it was built to be a leadership in sustainable architecture and environmental responsibility. This building has earned both the LEED Platinum certification and the prestigious Living Building Challenge certification. It produces more energy than it uses through the use of solar power and wind turbines on site. It's It shows what the capabilities of a genuine holistic approach to sustainable design and building can achieve, right? It was designed by the Smith Group JRR, built by Hurricane Construction, started 2012, finished 2014. The project total was 8.1 specifically for the center, and then approximately $21 million total for the whole 119-acre parcel that comes with this. Again, it's a stunning design, and there's a purpose for every design, extremely well thought out throughout this entire process. All right, so sustainable features. Again, I got a recap of the awards up there and include the AIA Cody Top 10 Plus. This makes this one of the most prestigious and decorated structures in the entire world, right? So we're using the coastline of Virginia Beach to provide wind power. We're using the sun in that area based upon the climate. Like everything is interdependent to this holistic approach. We use geothermal wells, providing a heat sink and consistent temps with VRF coolings. There's 18 VRF systems throughout this entire building with sensors for occupancy and such like that. It's a fantastic design. So for our building envelope, the building itself uses ultra high efficiency R value insulation and glass throughout the entire building, whether it's the roof, the walls. Uh, the roof has an R value of 51, which is just outrageous. And then it also does a reflectivity of 0.03, further reducing that thermal transfer. So not only is it capable of withholding all that internal interior air and temperature, but they even took it further to reflect most of the sun's heat so that it's not heating the structure. It's incredible. The structure itself is made to withstand 130 miles per hour, hurricane gust winds, and then being elevated 14 feet above sea level to help protect it from the storm surge. And what you see right here is a really good shot. We have a lot of light grass within the area to further help light reflectivity coming up through those windows and using a really robust daylighting strategy. Lighting and electrical. So all electrical generated by the 168 rooftop panels and 2 wind turbines. Again, we talked about, 60-40 split for the most of the time, some being more, other months, plus or minus. But the cool thing, this building has a monthly energy bill of $17.19, which is the minimum it needs to maintain a hookup. We have OLED lighting throughout the entire building. And as stated earlier, it relies heavily on daylighting through the placement of the windows and then celestial windows as well. Photo sensors in individual rooms allow occupancy, things like that as it increases and decreases. Those lights will go off and on. Just a huge, robust sensory system that helps maintain, limited waste of electricity, but providing maximum comfort to the occupants. The HVAC system. So we got a geothermal with a heat pump, right? There's a great picture. It kind of shows how this works, right? We can see our heat sinks right here. And then we do expose duct throughout the walls with air return grills. And that's a fantastic. We talked about some of that in our HVAC section in the book. We do have large overhangs, which is important to as the sun comes in, it's not hitting those windows directly. It's actually you're only catching the reflection off of the surfaces back in through the window, which will cut down on radiant solar heat. We also the use of radiant heat pipes through concrete floors in conjunction with the geothermal system. What I think about what's really cool about this is we're using the geothermal system for heating and air conditioning with a heat exchanger and then running it through those VRFs. It does have a 7-ton air condenser and cooler up on top of the building, which does help in some of the summer months. Remember, because in the climate change it does get pretty hot and humid during the summer months. Plumbing. This is really cool. So on site, rainwater is collected, right, in conjunction with composting toilets, right? So essentially what is happening with the plumbing, as the rainwater is collected, we're not having to maintain a constant pool from the city because the rainwater is collected and then cleaned, filtered, and then reused internally in the building for both the building and any kind of irrigation systems for outside to maintain that vegetation, right? The composting toilets, right, is really cool because as that water comes down into the compost, it's treated. That in turn is then used back on the site for native landscaping, fertilization, things like this, because this is constructed on a brackish wetland, right? That is kind of where this is at. It's amazing. We're not losing anything, right? A lot of people don't think about using potential waste, right? Because, it's kind of gross, but we're using it to the benefit of the site through a composting system. So the whole point that the Chesapeake Bay Foundation and that holistic approach is we're not wasting anything. Everything is being used. Rainwater, composting toilets. It's just like I said earlier, it is extremely well thought out and really adheres to that living building standard. Fire protection at the Brock Environmental Center, right? Really thorough for a building that is this sustainable, right? And again, we're using for our sprinkler systems the rainwater, and again, we're maintaining that hookup, but most of the water is kept on site in cisterns. Right. So it's got a passive and active fire safety that aligns with its goals under the Living Building Challenge. Material used throughout the buildings were selected not only for sustainability, but for fire resistant in case, you got to maintain those design standards and construction type standards. Key systems. So we have the automated sprinkler system, we have the fire system, and the fire resistant material, right? Use of natural untreated wood and natural insulation ensures safer performance in case of fire. Right. And then our fire strategies are carefully balanced with the water saving efforts while also using the rainwater harvest, as we talked about, is crucial. So again, even something like a fire protection system within a building has a lot of code and regulation that comes with it. So it is a kind of a hurdle for a design team to make sure that the fire protection system is sustainable. More often than not, you leave it hooked up to the city and you mark it as, having full pressure all the time. What JRR, Smith Group JRR has been able to do through the use of the cisterns and then the active rain collection is they're able to maintain the fire protection ratings through this sustainable system, which is, it's a very rare case that this is able to do that. And the fact that they did it through the systems that they have in place is, a fantastic kudos to the Smith Group. All right, there are mechanical systems. All this rolls into a net zero strategy. Again, we're talking about the holistic approach, right? And it's important, right, as the mechanical systems are probably the most energy consuming product on the building, right? But how it's laid out is that they work in harmony. We kind of touched on that a little bit, and now we're able to use less energy, right? So the geothermal HVAC using Mother Earth for her heat 300-foot deep pipes, low energy heating and cooling paired with high efficiency heat pumps. We talked about the VRS systems for the summer and then the heat pumps for the winter. It is fantastic. Our radiant floor heating, right? We're maintaining an internal temp through that radiant floor, provides quiet and comfortable and works well with the geothermal system. For those of us that have interacted with geothermal systems, radiant heating is fantastic. So it's great. The use of natural ventilation in this building is extremely critical to how air and internal temperatures are moved and maintained in the building. So there's timed windows at the upper part of the building that open at night. So as the temperature comes down, we're not having to continually run air conditioning units or maintain that 72-degree internal temp, right? Because we're using wind from the coast to come in, drop the interior temperature of the building by moving that warm air as it rises out during the night. So when you walk in the morning, you walk into a nice, cool building. Now, I'm sure on the hotter days, right, you're going to have to run some air at night, but most of the year, you're able to maintain a relatively comfortable internal temperature by this process, right? We also recover heat from outgoing airflow to condition incoming fresh air. So as a return units are taking that hot air, old stale air out of interior rooms, is running it back through with the incoming fresh air to heat or cool that air. So we're using less energy there. It's just a fantastic system. And then all mechanical systems are powered by renewable energies. Remember, this site, through the use of wind turbines and solar energy, produces all the energy it needs throughout the entire year. Systems integration. We have all these systems, but they're only as good as they are to be integrated. So the systems are connected to a centralized building automation system that looks over performance and makes sure operations going smoothly in real time. Right? It's fantastic. Fire and mechanical synergy. During fires, the natural ventilation system improves escape and minimizes damage by assisting in smoke and spreading of smoke to make sure it is safer. And then the ERV and HVAC work together to maintain indoor air quality, especially important in smoke or other emergency scenarios that may happen to the building. Right. And then the use of the geothermal, solar, and wind systems, right? The rainwater harvesting, all comes together in this system integration where each system is helping one another to reduce the energy load that the building consumes on a day-to-day basis. We have a systems drawing provided by our Kevin Lady. It's fantastic. Please check it out. And our conclusion. This is one of the best and environmentally friendly structures in the world. And that's what it comes down to. We have these great pictures and we kind of have a breakdown of how all of our systems and the purpose and the holistic approach to this building is laid there, and a beautiful picture of our building to show that it's using these wetlands, it's maintaining wetlands, it's providing back to the environment just as much as it's taking, right? This building for our class and for anyone that's really studying architecture or systems integration should be a very big focal point for study and for even future potential as newer technology and newer opportunity presents itself. Thank you. As again stated, this is Mason Graham in conjunction with Jeremy Lynn and Kevin Lady. We appreciate your time and thank you so much.